Hey guys, so today we're starting Unit 1 talking all about the atoms. So welcome to your first notes online. Let's do it. Oops. Oh my gosh. So we're going to start off by having you draw what you think an atom looks like. So chances are what you drew looks something like this. And that is not how an atom is supposed to look at all. So we're going to talk about what an atom actually looks like, and we'll kind of go from there and tell you all sorts of things about an atom. Hopefully you remember this from something, whether it's physical science or something else. But yeah, let's get into atoms. So here are three facts I need you guys to know by the end of the day. So now would be a great time to jot these down in your notes just so you have them. Cool. Hopefully you've jotted those down. Moving on. These are all the different terms that we're going to use today. So you should, by the end of today, have a definition for every single one of these terms. Cool. Okay, so this is an atom, specifically boron. If you look at boron on the periodic table, it's number, what is it? Yeah, number 5 on the periodic table, but of course, number 5 on the periodic table, number 1 in our hearts, right? So here's what I'm going to do. I'm going to show you in blue what a neutron is, in red what a proton is, and then electrons are just going to kind of be chilling out there. So 5 protons in the middle, 5, or I guess that's only 4 neutrons in the middle as well. This is typical. You could have 5 neutrons, you could have 3, but boron typically forms with 4 neutrons. The protons and the neutrons right there in the center, that's called a nucleus. So this would be a great thing to jot down for you, is jot down like, oh, you got 5 protons in there, 4 neutrons in there, and that whole thing together is a nucleus. And then you'll have 5 electrons kind of spaced out here in what we call an electron cloud. So these electrons could be anywhere in this cloud. I just drew them nice and evenly spaced out so you can see that there's 5 of them. But these electrons are not standing still. They're moving all over the place. The protons and neutrons are more or less standing still, just kind of like vibrating in their little spot. But the electrons are flying all over the place and in like a random path. Electrons are crazy. So that whole thing, this little sphere, that's what a boron atom is. Oh, and you'll see down at the bottom I put that it's not to scale. Boron atoms are not this big. They're very, very small, in fact. So yes, this is not to scale. There it is. Boron. Okay, so this is important to write down. Protons and neutrons are inside the nucleus and make up the mass. All of that is important. All of that is crucial. You'll notice in parentheses here, I put a little p with a superscript plus next to it. That's proton's abbreviation. So you'll notice on the previous slide, when we look at it, proton is a little p plus, neutrons are a little n with a 0 next to it. Yeah, those are ways to abbreviate proton and neutron, so you don't have to write out the whole thing every single time. So that's kind of a nice, cool shorthand. Electrons, you'll notice they're abbreviated lowercase e with a minus as a little superscript, so e and then a little minus up at the top. They're outside the nucleus, and they make up the volume. So protons and neutrons, they do have volume and they have mass because they're matter, right? Matter has to have volume and mass. But the amount of space protons and neutrons take up is so small that we say they practically have no volume. Electrons move around so fast that they occupy an area. We call that area the electron cloud. And they are so tiny that they practically have no mass, especially when you compare them to the protons and neutrons. Their mass is what we call negligible, in the same way that protons and neutrons have a negligible volume. So electrons make up the size, even though they're tiny, tiny things, because they move so fast. It's kind of like a fan blade. Like a blade individually is just like one little strip, but when it's moving around, it creates like a circle. Electrons do the same thing. They're this little tiny dot, but they move around so fast that they kind of create a giant sphere around the protons and the neutrons. So that's an atom. That's what it looks like. That's how it is. Oh, this is a helpful equation to jot down. Mass number, which is a term for the overall mass of the atom, is protons plus neutrons. Remember, protons and neutrons are the things that make up the mass. So if we wanted a mass number or a total mass of the atom, we take protons and we take neutrons. Protons and neutrons weigh about the same. They weigh 1 atomic mass unit, which is a unit that we created so that we could just make it easy, because the amount of like kilograms they weigh is like 1 times 10 to the negative 34th. So like really, really small with lots of zeros after the decimal. So for example, 118 atomic mass units is the mass of tin. Cool. Atomic makeup. Let's talk about the nuclear symbol now. Everything you see here, the 12, the 6, and the C, that is an example of a nuclear symbol. So what I want you to do is write down nuclear symbol in your notes and then copy down this 12, the 6, and the C as an example of it. We're going to go over what the C means, what the 6 means, and what the 12 means. So if you're not sure what those numbers mean, we're going to talk about it in a little bit. So get excited. Okay, so nuclear symbol is the whole thing. The element symbol is just the C, just the letter C. Every element has an abbreviation. Most are pretty common, like C stands for carbon, for example. B stands for boron, which is one we saw earlier. H stands for hydrogen. O stands for oxygen. Some of them are less straightforward. We'll get into those later. But the element symbol, it identifies the element. It's just a letter abbreviation. So write that down about element symbol. And then I would find maybe a different color to highlight the C from your nuclear symbol. Just highlight the C specifically. And then you can write down that that is an element symbol. Okay, so here's what I want you to do. I want you to use your periodic table to figure out what is the element symbol for fluorine and what is the element symbol for copper. Fluorine is F, copper is Cu. Woohoo! Hopefully you can use your periodic table. If you couldn't find those, fluorine is number 9 on our periodic table, but of course number 1 in our hearts. And copper is number 29 on the periodic table, but also number 1 in our hearts. Okay, now we're going to talk about nuclear symbols. Or sorry, no we're not. We already talked about that. Now we're going to talk about atomic number. Atomic number is the 6 down here. That stands for the number of protons. So when we say number of protons, we could also say atomic number. Those two things are the same. They mean the same thing. So atomic number is the same thing as the number of protons in an atom. Fun fact, each element has a unique number of protons. So if I were to take a carbon atom and remove 1 proton, then I would only have 5 protons, which is boron, right? So by removing a proton, I change the identity of the element, which is kind of cool, but also it's very hard to remove a proton. So usually atoms don't just spontaneously change into different atoms. We don't often see that unless there's some funky nuclear stuff going on. Oh, fun fact, the atomic number is also the number of electrons in an atom. Usually, when we talk about ionization next unit, we'll talk about how electrons change. And electrons can change way more easily than the number of protons. So electrons are kind of tricky. But for now, for the purposes of our class, the number of protons you have is the same as the number of electrons you have. So carbon would have 6 protons and also 6 electrons. That's what we're saying. Okay, we just answered these questions. Take a moment to answer them yourself. How many protons do you have? If you add a proton to carbon, you've got 7 protons. Now the question is, what happens to carbon? Check your periodic tables. It'll tell you that if you add 7 protons, that's how many protons nitrogen has. So now, instead of having carbon, you turned it into nitrogen. Kind of cool. Okay, we talked about nuclear symbols. Now we're going to talk about mass number. The mass number is the total number of protons and neutrons. You should have heard this already when we talked about the equation. Protons plus neutrons equals mass number. So we're going to ask you guys, we're going to give you like a number of protons, and we could also give you a mass number, and then we'll ask you the question, how many neutrons does something have? So feel free to write this equation down, mass number minus protons equals neutrons. This is using the same equation. I'm just subtracting n from both sides. So I move this over to the mass number side, or sorry, I'm subtracting p from both sides. So I move p over to the mass number side. It's just rearranging the equation. These two things are both equally true because as we know in math, we can just rearrange equations to say new things that are ostensibly the same as what you said before. Mass number, that's the number at the top of the nuclear symbol. Oh, and then remember, number of protons is the same as your atomic number. So you could substitute P plus for atomic number, and then you'd get the number of neutrons as well. Either way. Yeah, we will either give you this or you'll have to figure it out, the mass number. So we'll either tell you the number of protons and neutrons, and then you'll have to calculate it, or we'll just give it to you, and then we'll ask you to find the number of neutrons, for example. Okay, here's a great example of finding this out. If you have 13 protons and 12 neutrons, what's your mass number? And what would your nuclear symbol look like? So use everything you know about protons, everything you know about neutrons to put this all together. Here we go. The mass number would be 25 because 13 plus 12 is 25, so you're adding them. And then 25 goes on top, where your mass number does. 13, the number of protons, goes down on bottom. And then if you look at the periodic table, you find number 13 over here. You'll see that it is, oh, it's aluminum. That guy right there. Yeah, hopefully you can see that. So use your periodic table to figure these out is what you want to do. Okay, you've already seen this before. Protons and neutrons in the center of the atom make up the mass. Electrons are outside the nucleus and make up the bottom. You've already seen this before. Here's a nuclear symbol, this whole thing. The element symbol is just the carbon. Here's our atomic number. Atomic number is the same as number of protons or number of electrons. This might be helpful. I don't know if I've really written it in this way. Hopefully you have something like this in your notes. Right, that atomic number, the number at the bottom, is protons plus and electrons. They're all the same, not plus. So these are all equal to each other. So 6, 6, and this would also be 6 for the atomic number. Mass number is the one up top. That's protons plus neutrons. I hope you noticed that I tried to color code these as well. So hopefully that makes it a little more visual. We already talked about this. It turned into nitrogen. We already talked about this. The one thing we didn't talk about is isotope symbol. So here's what an isotope symbol looks like. You write down the name of the element, then you put a dash, then you write down the mass number. So my definition for isotope symbol is name of the element dash mass number. That's what it looks like, and here's an example. Carbon dash 12. Remember, the mass number would be the one on top of the nuclear symbol. So here's the question. What does nitrogen with 7 neutrons look like? Think. You should know how many protons nitrogen has. And then what does nitrogen with 8 neutrons look like? Think. You should know how many protons nitrogen has. So nitrogen 14, 7 protons plus 7 neutrons gives you 14. So 14 is what you write down there. And then with 8 protons, or 8 neutrons, it would be nitrogen 15. If you changed the number of protons here and said 16, that's wrong, because remember, protons determine what the element is. So if you wrote 16, then you would have oxygen, right? And that would be wrong. Fun fact, nitrogen 14 and nitrogen 15 are actually different atoms. So we call these isotopes. Here's what I'm talking about. An isotope is something like this. You got lithium 6, lithium 7, and lithium 8. Notice they're all lithium. They all have the same 3 on the bottom. And if you look at the picture down here, that's 3 protons, 3 electrons for each of them. 3 protons, 3 electrons, 3 protons, 3 electrons. What you'll notice is different is those brown neutrons. We've got 3, then 4, then 5. So here's what an isotope is. Atoms that have the same number of protons and electrons, but different number of neutrons. Sometimes we just shorten that to same number of protons, different number of neutrons. So an isotope will have a different mass. That's the key here. So you see those mass numbers on top, 6, 7, and 8. Those are all different because the neutrons are different, right? Neutrons and protons both affect mass. And remember, mass is protons plus neutrons. Okay. Do you notice how they're all kind of related? So really, we're just focusing on what does each part of this nuclear symbol mean, and then what are some different terms we can use to describe them. But you'll notice that there's a lot of carryover where a lot of terms mean one thing and also another thing. So just be aware. This is kind of confusing, but once you get the vernacular down, it's going to really help you understand what's going on in the worlds of atoms. So you could also write these down as lithium 6, lithium 7, and lithium 8. So that's isotopes. Here, moving on, I want to talk about the differences you'll see between what we've shown you so far with nuclear symbols and what you see on the periodic table. So if you took a look at the example we've been giving you this entire time, this is carbon 12 right over here, 12, a mass of 12, 6 protons, which means then 6 neutrons, because 6 minus 12 is 6, and carbon. Now, if you look over here, this is what your periodic table looks like. The 6 is up at the top corner. You've got a C, and then it says carbon, and it says 12. So from left to right, we've got nuclear symbol over here, and then we have the element card on the periodic table. They look very similar, but they are different. This is where kids get mixed up a lot of the time. So I'll talk about it. Element symbol is the same for both. They're both carbon, and they're both in the same place. The atomic number is in 2 different places, though. For the nuclear symbol, the atomic number is in this bottom left corner, whereas on your periodic table, your atomic number will be in that top right corner. Also, your periodic table tells you what the name is, always. You don't have to write the name down here. Now, the last part, this is what kids get mixed up on all the time, is the difference between 12 and 12.01. 12 is a mass number. It's an atom, or you could call it the atomic mass. It's the number of protons plus neutrons for one specific atom. So we're just looking at one little carbon sphere. Over here, the 12.01 is the average atomic mass. So it's still protons plus neutrons, but now we're taking a sample size of every single carbon atom, figuring out what all their masses are, whether it's 12 or 13. I think there are some other isotopes like carbon-14 when it comes to carbon dating. So carbon-12, carbon-13, carbon-14, you average them all out and you get a number of 12.01. This means that the vast majority of carbon atoms are carbon-12, and then very few are carbon-13 or carbon-14. So the key difference between these two, between the nuclear symbol over here and the element card on the periodic table, is that the nuclear symbol is for one specific atom. That's the key there. Versus the element card on the periodic table, this is talking about every single atom, all atoms that are carbons. So hopefully that makes sense. The moral of the story is never use this 12.01 number. Never use a number with a decimal point when you're talking about mass number. Mass number should always either be calculated by adding protons and neutrons, or it'll just be given to you when it comes to nuclear symbol. Sound good? Cool. Let's move on to the practice problem. Okay, here's some questions. What I want you to do is figure out protons, neutrons, and electrons. You will need a periodic table to do this. You couldn't just do this by yourself unless you got the periodic table memorized, which I do. Let me tell you something. Actually, try it out first. Cool. Hopefully you've tried it out. Here's a fun fact. Uranium has 92 protons. I know that just because I'm so good at chemistry, right? Didn't even have to look at the periodic table. I just know it off the top, right? For those of you who couldn't find it, it is number 92, and it is down here in the lanthanide section over there. Or actinide, I guess is what it's called. Number of neutrons, you'd have to subtract 92 from 238, and you'd get 146. And the number of electrons would also be 92. These numbers are always the same. So then to finish off this little nuclear symbol here, we would just put a 92. This is what one of your quizzes will look like. We'll give you information about a certain element like silicon. We'll give you enough information so that you can fill out the rest of these 3 boxes, and also this guy right down here. Let me show you how this works. We know silicon has an atomic number of 14. Atomic number tells you protons and electrons. So we know that we have 14 down here, 14 here, and 14 over here. Then what we have to do is take 14 minus 29 to get 15. That's our number of neutrons. Go ahead and try this out for phosphorus. I told you phosphorus and the number of neutrons. Fill out the rest of this. You can do it, but you will need a periodic table to finish it up. Cool. Hopefully you tried it. Here we go. Atomic number for phosphorus is 15. You find that on the periodic table. Here it says right here, phosphorus 15. 15 goes on the bottom then. 31 goes on the top because 15 plus 16 is 31. And P is our little element symbol. This whole thing is our nuclear symbol. You have to include all 3 parts for it to be a nuclear symbol. Mass number is 31. Remember, those two are the same here. Protons is 15 and electrons is 15. Cool. All right, that's all I have for you guys today. Thank you so much for tuning in. Have a great rest of your day. We'll see you later. Bye-bye.